feel like everything's been very relevant to me today. Not only am I, also smashing ClickHouse, because everyone must do that, but I'm riding in an event this weekend, so anytime anyone mentions cycling, I get a little bit triggered. Cool, so we'll just double check this works. Nice. So I'm Adam, I work at Hasura, and I'm a customer engineer. What that really means is, as customers are starting to evaluate things like Hasura, I work with them and I help them, make it work well. So a little bit about me. I'm normally based in Sydney, but down in Melbourne quite frequently. I have customers all across Asia Pacific. We mainly work with banks, financial services, large healthcare companies, really anyone who has a degree of kind of highly regulated data, because things like authorization are really important when it comes to data access. I'm known in most places online as Typhonius. It's a long story. Come and grab me afterwards and talk about that. And I work normally in the state emergency service because it lets me get on buildings and use chainsaws and all other kinds of fun things. Bit of a kind of a run through around what we'll talk about today. So we'll talk around kind of our original observability stack that did not use ClickHouse. We'll learn a little bit around open telemetry and why it's important in things like observability. So, on Johnny's example, observability use cases, that's us. That's what we're doing at Hasura. We'll look a little bit at our evaluation because we wanted to understand where we should be placing all of that observability data. Should we be using something like BigQuery? Should we be using ClickHouse? And then I'll be running through what our current state, and I'll put in an asterisk, beta is on this one. So it's our beta product that is going to be launched sort of mid to this year. The other thing, because we're all here to see it, I'll do a little bit of a demonstration of Hasura connecting up to ClickHouse. So to kind of wind us back and to set some context, I want to run through API patterns in enterprises. Now, for the most part, this is what a lot of organizations set up. And you're probably kind of situating yourself down here in the domain team who owns a whole bunch of data. Or you're probably up here and you're like, I make apps and I connect to APIs that my domain teams get me. The challenge is that when we're trying to create a lot of really good experiences, because ultimately that's what happens, right? The product team says our customers need these kinds of things. We need to create a lot of different APIs that connect to lots of different backend microservices. And oftentimes the challenge is how we create these APIs, how we create these connections between things that we don't necessarily always own or have good visibility over. The bottleneck comes into play because the product teams move really quickly, and the data teams behind the scenes kind of say, we understand you want to move quickly, but we've got to take into account things like security and scalability and efficiency and queries and all of this kind of thing. So there's a bottleneck in place. Now, when we start thinking about APIs as well, anyone goes, yeah, it's really easy to build an API. I'm sure everyone's built the most simple CRUD API, probably right. Hands up if you've built a simple CRUD API. Sure.
I've built many shit ones.
Most of mine are shit too.
Yeah.
The challenge is that to build a really good enterprise-grade API, it's not just a request coming in and hitting a backend. It's managing and negotiating connections with lots of different databases. For example, on here I've got Aurora, I've got Mongo, I've got ClickHouse. I might be pulling information from multiple different sources and then rationalizing it all together. Then you're falling into problems like the N+1 problem, which means you're hitting one database, you're getting 50 results. Does that mean that you have to make 50 queries to the second database? And so on. Ideally, no. You might also need to start thinking about things like authorization. So when it comes to security, how do we make sure that I don't see other people's account details and vice versa? I'm very poor. I don't want anyone to see that. I might also be thinking about things like caching, because it's, again, important to retrieve those results really quickly, especially if this query down here is super expensive. We might also need to think about things like business logic, about events, and observability. So the creation of an API itself isn't just let's kind of whack up a quick Python API or Node API, slap something in Express and deploy it. It's actually a whole process to ensure that we're making data and data access safe, secure, fast, performant, efficient, all of that kind of thing. So where Hasura comes in, and this is the brief bit about Hasura, is that we create all of that automatically for you. So anytime you have a data source, whether it's Aurora, RDS, or MySQL, or ClickHouse, or Mongo, or Postgres, or anything else, we will connect up natively to that and automatically generate an API in both GraphQL and REST that allows you to pull information up through Hasura's supergraph and then ingest it and use it in whatever applications you want. So it really saves time, allows developers to build a lot faster. So, onto observability and how our cloud used to do observability. Kind of looks a little bit like this. This is kind of the high-level architecture of Hasura Cloud. Now, we're going to be speaking mainly about this stuff over here in the control and monitoring plane. But effectively, what our cloud does is it will spin up a whole bunch of different Hasura instances. It's fully horizontally scalable. We don't hold any state. And we can connect to any different back-end service, whether it's Mongo, MySQL, Postgres, that kind of thing. Now, all of our cloud instances are going to be sending a whole bunch of data to our observability platforms to make sure that not only can we see them, but also our customers can see that data as well through the monitoring dashboards in Hasura Cloud. Our current infrastructure kind of looks a little bit like this, and this is kind of the current old infrastructure. So there's log services, there's metric services, we've got Prometheus in there, we're storing a whole bunch of data and data products and data analytics in BigQuery, we've got some timescale databases, and then on the observability side, we're tracking things with things like Jaeger, we're making queries, I think probably through BigQuery with Metabase, and we're storing a whole bunch of logs in Honeycomb. So there's lots and lots of different services that we're using that's not really performing how we wanted it to perform, especially as we're starting to create more data products that our customers can use to analyze and observe their own data. So the more that we use this, the more challenging it becomes for us to actually open that up to customers. And that's kind of one of the value adds of Hasura Cloud, is for them to be able to evaluate and look at all of their own logs and tracing information to make sure that their platform's performing really well. So we start thinking about the considerations. In terms of kind of observability as a whole, we typically think of things like logs, metrics, and traces. So our logs were getting pushed out into Honeycomb. Customers weren't really being able to see those because Honeycomb was an internal platform. Our metrics were getting pushed through Prometheus. Again, same thing, that Prometheus was locked off into Hasura. And our traces in log format were again being pushed into Honeycomb as well. So while we could analyze a lot of these things were being analyzed in isolation. So we can't start to do things like distributed tracing and matching up a log line with a span coming from a trace, because everything was stored in different systems. So we had to start thinking about, hey, how do we engineer new things that will sit on top of all of this and draw it all together? So it becomes a little bit more complicated in order to look at the holistic picture of everything in one go. Because effectively what we want to do, if we see an issue, if we see an error, we want a metric to fire off some kind of alert that says, hey, our latency is increasing over the last 24 hours. We then want to start looking back in our trace logs to see, okay, which service is slow, and then we want to marry those trace IDs up with our logs to see exactly which of those services may be increasing error states or other things. So because we can't join those signals together, there's no real single view of the activity on Hasura Cloud. We started to think about using OpenTelemetry because OpenTelemetry is not a standard that we invented. It's kind of the de facto standard that a lot of organizations now use for shuttling this kind of information around. So if you're using something like New Relic or Splunk or Datadog or Dynatrace or fill in the blank for kind of your selected platform of choice, OpenTelemetry is the standard that a lot of organizations are moving to. Now, the kind of things that we wanted to create were not just the information that we could see, but also a lot of these customer-facing monitoring and alerting solutions. And so if we can start to use an open standard, if we can start to use a specification that everyone uses, not only could we show it in our dashboard, but we can allow customers to surface it in their own dashboard. Now, we're an open source product, so we want customers to use their data as much as they want, and it will make it a lot easier for customers to do if we start aligning to standards that everyone else uses. So a little bit more around aligning to standards and what OpenTelemetry is in case folks aren't aware of it. I want to dive a little bit into logs, metrics, and traces here. Now, logs themselves, they'll document every single action that occurs within, in our case, Hasura. But if you've set up a web server, anytime anyone from some random country hits your web server, there'll be a log that says this IP did this and that kind of thing. It's really useful for understanding traffic and understanding patterns, but also starting to understand, are there security events? Now, a typical log looks a bit like this. That's impossible to read, so you need some kind of layer that will help you to start aggregating the many, many thousands of these that happen every second. and start to aggregate it all together to help you work out, what that's actually showing as a pattern. A metric is usually something that we're going to be querying, once per second, once per 5 seconds, once per 10 seconds to understand the state of the solution. And metrics might look a little bit like this, and this is something that we might be querying through something like Prometheus. And you can see a whole bunch of different metrics here, and these will change every time we query the metrics endpoint. Maybe we've got, the event fetch time. Maybe we've got the number of invocations, the number of HTTP queries that have happened. And this is really useful for creating dashboards like this. And because metrics are usually based on timescale, we can start using something that Google invented called golden signals analysis that says, hey, we don't really know what's happening in this black box, but we do know that latency is trending up or error rates are trending up. And that means that we should take some kind of action. So proactive monitoring before you have a whole bunch of red dashboards in there. So that's logs and metrics, and traces are a way of understanding exactly what a request does as it traverses your infrastructure. So, a trace may come in through, say, Nginx as your ingress point. It may hit your web app. It may run through a little bit of checking. It may talk to your auth system. It may then hit your database. The database might do some things, and then it will return all the way back through those steps. It's kind of like internet plumbing. So a trace looks a little bit like this, where this is just for Hasura. You can see that Hasura has understood that there's some kind of hit to its GraphQL endpoint. It passes the GraphQL, it creates an execution plan, etc., etc., etc. And we know what's happening at every single point in time. And these kinds of things exist for all different systems. So if you imagine starting to put them all together, you can go through everything that happens in Nginx, through everything that happens in Hasura, through everything that happens in your database, and so on. So what we can look at here is, like, let's say, this one here looked really long, like maybe it was, half a second or something. We know that there's an issue in that particular step of the execution. So we can drill down right into individual component parts of the execution to understand exactly what the issue is. So in terms of open telemetry, what we do in both Hasura and Hasura Cloud is we can push that information via open telemetry standards into any other service. Now, what we wanted to do with Hasura Cloud, though, is we wanted to push it all into one system, because this is what we've done before. We've put things in lots of different places, and we haven't had a cohesive strategy for then being able to review that without having to build a whole bunch of additional things in order to glue everything together. And so that's where our evaluation into things like ClickHouse came in. Now, the original approach that we took was to start thinking about, okay, do we want to use BigQuery or do we want to use ClickHouse? Now, originally, BigQuery seemed like a super attractive option because for us, it's a service from Google. We use GCP for all of our customers. We're on all 3 major clouds. So using some kind of service from a partner seemed to make a lot of sense, probably from a commercial standpoint. I don't know about that. And also just from a partner standpoint as well. The challenge that we had, though, is that because with observability, we're going to be generating thousands, tens of thousands, millions of logs and traces and metrics every second, there was no real literature to support BigQuery being able to do a whole bunch of ingestion really quickly. And starting to think about how we wanted to look at that information, creating things like materialized views that are automatically updated to create real-time information, there wasn't really that level of support that we needed from BigQuery. So what we did is we started a proof of concept over in ClickHouse. And we looked at a couple of, these were, I went to our engineering team who actually built the POC, and these are a couple of the resources that they provided us. Now, in terms of what the ecosystem was doing, and I've got a couple of architecture diagrams in a second, effectively we're going to be pushing huge amounts of data in, almost one by one, into ClickHouse. And then at any time, any customer is going to want to look at their data, so we're securing by authorization the information that is in their ecosystem. So for ClickHouse, what we had is huge amounts of inserts while we're materializing, a whole bunch of different views. We needed fast data retrieval to make sure that customers weren't waiting, because I can't remember who it was earlier on, but it's that attention span, right? We want customers to see the information in real time as soon as it's in the dashboard, especially if they're making requests and they want to see exactly, within a kind of a second what the trace of that was. And then we wanted the ability to scale infinitely as well, because we're hoping to obviously have lots and lots more customers. So we don't want to be capped by some kind of artificial limit of data source. So now looking at the architecture that we're going to, and this is that, asterisk beta architecture that we've released. It's up, it's on cloud, and I'll show you a little bit of a demo of this later on. Now what we're doing is this. Everything that we're doing across every single one of our regions, and we're deployed across AWS, GCP, and Azure, is sending information from a whole bunch of different sources via OpenTelemetry exporters, directly into ClickHouse Cloud. So we're pushing information for logs, metrics, and traces from all of our regions into ClickHouse Cloud. What we'll then do with that data looks a little bit like this. So if we're the customer, then the customer's kind of, probably going to have some kind of back end for front end to generate that front end, generate the Hasura dashboard, generate the Hasura console, and then there'll be some kind of microservice to send SQL queries to ClickHouse, with ClickHouse obviously providing that raw data ingestion and aggregations via materialized views. This, though, to me, this looks a lot like magic. I could just say, hey, just go and create, just go and write your own BFF, go and write your own microservice. So I'm going to go one level deeper into what we actually did. Because for this approach here, we'd have to probably handcraft a bunch of queries. And anytime we wanted to add new features, we'd have to handcraft new SQL queries. And so we looked at our platform and we said, why don't we take this bit out here, and why don't we just use Hasura? And we haven't created a ClickHouse connector yet, so why don't we create and open source this ClickHouse connector, which will effectively mean that, yeah, we can use our own product, we can quote unquote eat our own dog food, but anyone else who wants to use ClickHouse in any other example or any other product can do so with Hasura very, very easily. So, starting at the client, this is exactly how it works with ClickHouse. We'll create an API endpoint automatically with Hasura, and we'll take some kind of smart way of creating a query, again, whether it's in GraphQL or REST. The Supergraph API, which is responsible for connecting up your ClickHouse with your Postgres, with your Mongo, with everything else, that's part of Hasura, will do all of your API validation, your query validation, your authorization, your routing, and everything, and it will push it into an Hasura instance. That Hasura instance will then generate all of the authorization parameters, and it will look at, for example, maybe the email address or the bearer token or these kinds of things to say this person has access to these different platforms or projects within Hasura. It will then send that up to the ClickHouse connector with the authorization parameters. So it will say, okay, there's that request that we've got. We've also generated the authorization parameters to say this person can access these different projects. The ClickHouse connector will then automatically generate optimized SQL that runs against that table or materialized view and includes all of the predicates based on authorization. So you see here, this person down here has asked for the traces, the trace ID, the span name. Hasura has said this person can only access myapp.hasura.app, and we've automatically built those predicates in by default. And that's something that Hasura does very, very well. It builds all of the authorization parameters in. So looking at what we receive as a result, every single query, this is all now starting to come out of ClickHouse, where we might create a query, and Hasura will be able to understand exactly how that happens, all of the traces that go into that, and also, because we're working in a fully distributed manner, where my Hasura endpoint is, where my ClickHouse endpoint is, where the connector is as well. So I think let's run through a real quick demo. I've got two demos to show you. Both of them are going to be a couple seconds. One is the, which way do I want to do this? I think one is going to be the new way, which I don't have ClickHouse for, but imagine it. The second one is going to be the connecting Hasura up to ClickHouse and showing how we can pull that all in automatically. So the first thing that I want to show you is how quickly it is to connect up to a data source. And what I'm going to do here is I'm going to pull this in, and what we've got available in things like our connector hub here is the ability to connect up to ClickHouse. What I'm going to show you very quickly is I'm going to show you an example with this this example Postgres database, just because Postgres is the one that we've got an example data source for. Now what Hasura is going to do, and this is what you'll see in a second in my second example, is it's going to analyze the data source, whether it's Postgres, Mongo, ClickHouse, anything like that, it will understand any relationships between any of the different data sources, and then it will build the API for us automatically. So that means that we can now start to query any of our different data in here. We can run a query like this, and then we can view the trace, and this trace is pulling information immediately from ClickHouse. So the query that I just created and ran, that information will be pushed into ClickHouse, and then we can start looking at all of that information, all of that tracing information down here in real time. So it happens really, really quickly. All of this is governed, of course, by things like authorization. So I'm only going to see, in this case, this request. I'm only going to see requests for projects I own. It means that I can see the data, I can see anything in effectively real time. Now the other example, and this is where we start using ClickHouse in a little bit more detail, this uses the current version of Hasura. And this is, as you can see, kind of an empty instance of Hasura. What I'm going to do is I'm going to connect my ClickHouse data source up. So this is the ClickHouse connector that we created and open sourced. And because I'm super conscious about my own security, I've given it no password, and I've given it the username default. So we'll connect that up, and just as you saw before with Postgres, what Hasura has done is it's gone in here and it said, cool, you've got 3 tables and a materialized view. And we can track all of that information and make that available immediately via the API. So where before there were no queries available, what we can see now is that I've suddenly got all of this information that I can pull from ClickHouse. Now, I'm not going to do a select star because I've got, I think, like 10 million rows or something in here, so I'll just do a quick limit of 10. Now we can see here that I've got information from lots and lots of different people, right? So I've got, this GUID, I've got this GUID, I've got this GUID. So right now we're not actually doing any authorization. I just connected ClickHouse up, and I've created my API for ClickHouse. So what I can now do is I can now come into my data manager, and I can start building any kind of permission for any of my different CRUD operations on top of ClickHouse. Oh, sorry, on top of Hasura, and that will automatically build those predicates into the query that runs against ClickHouse. So I'll come in here and I'll say, let me build a custom check. And I want to make sure that the GUID matches, let's say, X Hasura member GUID or something like that. Now this value here could come from a bearer token, like a JSON web token. It could come from a secure header. It could come from a session variable, or it could come from a separate auth handler, which was like the example that I showed earlier on. So what this is going to do is it's going to only show people the results where the token value they pass to Hasura matches the value that ClickHouse has stored against it, and will automatically build the query that runs for that. I can also only restrict to certain columns. So I might say, hey, you can see the GUID, you can see the timestamp, but maybe only the call duration, not the call type, and something like that. So we start to provide authorization across both rows with role-based access control, attribute-based access control, and columns as well. Now, looking at this API, nothing's changed because I need to add in my Hasura member GUID, and I need to find someone's GUID actually. Let's try that. Let me pick a GUID. Let me pick this one here. And so if I place that in there and then tick this box, what we should see, I need access to a role as customer. Is it customer? Or user? There, user. So what you'll see now is that where before I had all of my data, all my tables, all my materialized views, I now only get access to one, and I've lost the ability to query my call type. So let me remove that, let me run that query, and now we only see information for that GUID. Because what Hasura has done, if I analyze this query, is it said in ClickHouse language, it said select these rows from this database, from this table, where the GUID equals this. So it's automatically built all of those predicates in without us as the application developer or the mobile app developer or the front-end developer having to worry about building that authorization into the query that I send. From a front-end perspective, whoever's consuming from Hasura, we just say this. We just say, hey, I want all of my information from the CDR table. And then Hasura goes, cool, let me get you that, but with these additional where clauses that are built in on top of that as well. So there were some demos. Hopefully that was interesting. I'll take any questions now if you have any.